Um, you are given a string, a target string, and you have uh, a list of words, okay,
A list
and
of
words,
words. Okay.
and you have a target string.
Wait, what the black word?
Okay, okay. We got a target string.
A target
Okay.
string, and uh, please answers. Please provide an answer that how many ways to combine the words from the list into to make the target string
The links to
by the
the target string. Oh, okay. Um, so I have a lot of question to clarify. Can we like we don't need to care about the order of the list of words, right? Right. The order of this,
the order.
yeah, of the
The
list of
order.
words.
Yeah, that's right.
Okay, okay. So 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 we just need to care about the value of each word in this list instead of the order. Okay.
Yes,
Okay, okay. An order. Um, so it is any duplicated word in the list.
yes.
Duplicated. All right. All right. Okay. So for example, like I got a list of words like this, B, like B, B, B.
The cards included too.
Okay, okay.
Okay, I'm back now. So
So the taller string uh, got something like A, B, C. There's actually A, B with C here one way.
mhm.
A, B with C one way. Oh, sorry. Like this, it could be A, B, C two. So there's two way, right?
Yeah.
Yeah, for example. And for example, in this case, it's gonna be three ways. A, B, B, and this A, B, B. And sorry, this is C. This is one way. This is the second way, and this is the third way, right? So I got so is three. Is that true?
A, B, C. You can split the first one by index term. Provide the list of index. So, for example, you have like the first one, and the second one is gonna be you like one, and the list of index by one, only four, and yeah. Mm,
And one and
I think
one three.
I think we actually the list of work is unique for more simplicity.
Okay, so I gotta delete this. So I got two.
Yeah.
Okay. Okay. So are there any constraints for the length of the string and the array, the list
The
constraints?
constraints. Just do do your best. Yeah.
Okay, okay. So okay. So we only need to return the number of result instead of the combination on the combination. The number.
That's
Okay,
right.
number.
So if the answer is too long, you can put the remainder of the sum. Yeah.
So I think it's
Remainder of a billion plus seven.
yeah, okay, okay. I got it. Um, So uh, the I think the really naive approach that I'm thinking about is like try to generate anti-permutation. Um, so just and for each permutation, I will concat it from the beginning, from the left to the right, and to check if the concatenated string is exactly equal to the target string. So we increase the count by 1, and this is gonna take us about and the size of for example, n is the size of the array, so it's gonna take an n factorial or n factorial, so it's gonna really large, and we need a more optimal way to solve this problem. So actually I'm thinking about using some approach like dynamic programming. Let's think about it a little bit here, like let's call DPI mean number of ways we formulate the target string numbers, the way to formulate to create to formulate the prefix t, the target string, from the begin to the I position. Sorry, prefix of length I, for example, length I, like maybe DP1 is actually the ways to form A, and DP2 gonna way to form AB. That is, and so on. And to do this, we could use a relevance formulate, like calculates based on the sub problem. Like we got a J index. Actually, J is smaller than I, and if the string from the target here is from the J plus 1 to so the way to form the prefix of length I could be the sum of the ways I form the smaller prefix plus if there's a string if there's a substring included in the A array, for example, like we got the string ABC here, and actually is to formulate the string ABC, we could formulate using the number of ways to formulate 8 plus if there's a string BC in the list of word here, and or from the number of ways to formulate this prefix AB plus if there's a way to formulate if there's a string C in the word in the list word. So for example, we got and the base case of this is DP is maybe number of ways to formulate the zero length string is 1, and for example in this specific case DP1 gonna be 0, 2 because there's no way to formulate the prefix A, maybe, yeah. And the BP2 is the number of ways to formulate this prefix AB is actually there is equal to DP0 plus if there's AB in the string. Actually the DP0 here is the string the empty string plus the AB to formulate the result of AB. This is empty. Okay, this is A, this is AB. So it's actually there's one AB in the list, so result of we plus with some the DP0 and check DP1. Actually DP1 is string like A, and we need to add the string B, to append it to the previous result, like, but we actually got a B here, so we gonna plus DP1 So actually the number of ways to formulate the string AB is gonna become the number of ways to formulate the empty string plus number of ways to formulate the prefix of length 1. That's exactly one ways. As you can see, we only got one way here. Okay, and then the last case to formulate the final string, the ABC, actually is equal to 0 plus ABC. Actually there is no actually there is one ABC in the string, so it's gonna be we need to add the dp0. The next case is something like this, and actually there's no BC in the string, so ignore this case. And the last case AB plus C, there actually there is one C, and the dp we need to plus dp2, and the answer is 2. So that's my solution for this problem. That's using dynamic programming. So in the subproblem, like the subproblem here is the number of ways to formulate the prefix of length I, and based on that we will append the string that already in the list, and check if we can formulate the target string of prefix of length I. So much.
Okay.
So your
solution. What is your runtime?
Okay, so as you can see, we need to iterate for each length of the t, so it's gonna be on, and for each state we need to another loop in order to check every prefix subproblem. It's gonna be n2, and to check if a string already in the list, we could use a set or a hash map, and actually it's gonna take the length of the string we're gonna search here, and to sum up it's gonna be the length to sum it's gonna be the length of the string target here, so it's gonna be something like this, on with n is the size of the array, and L is the length of the target string. This is my solution. Time complexity. The space is on only. So
sorry. So why this is why is the
what are you concerned about? If there's any concern about this?
if you gain optimal, what is your expectation? You gain optimal to the better version. So what is your time proceeding?
Can optimize this.
So I think you have missing something here. Why the n is decided right? Because I think you can only evolve to the length of the target string, not only.
Yeah. Sorry. My mistake. So
that's it. So just turning back to the time complexity. What is your time complexity?
Oh, okay. So let's call L is the length of the target string here, and actually we need to dp the space ot because we need to calculate the prefix of t, so it's gonna be ol. Sorry. And okay, so the dp is gonna iterate each length, its prefix of the target string, so it's gonna be on, and it's gonna another 4 nested loop to check every prefix. Sub problems are gonna be n, l, and it needs to look up in the list of word here. We could use a map, so it's gonna be O1, but actually we need to hash the string, so totally it's gonna be n2, so the overall is n2 3. This is the overall complexity of the problem. Yeah, but I think we could do it better by reduce the searching complexity. Like as you can see when we are okay, for example, I iterate up, but first of all, do you think my solution is kind of feasible? Like,
Yeah. I think that's correct. Yeah. So how you can optimize and what is your current bottleneck and
yeah, so I think my current bottleneck is the checking function to check if a string is already in the set. And I think we can optimize this by actually look at this formula. You can see I will iterate every tray less than I, and actually we could iterate from trace e minus 1 to 0, and you can see the string gonna be the search string gonna be something like maybe C. For example, ABC is gonna be C, then BC, then ABC, and you can see the thing gonna change here is it's gonna add new character. So I wonder if we could use a data structure that could quickly search for a string in the set in this set. But actually the change is just a character that we could append a character. So I think about using try like start from empty string, start from C, and we search on it on the try, and then if we found then okay, if we found, then this we could add the DP to the answer, and then we iterate to the next tray. In this case, tray is the like for example the ABC, in this case ABC, so tray is gonna be we calculate DP 3 and we test tray 2. Actually that is a string C here, and then we move to the tray equal to 1. The string gonna become BC, and if we search in the try here, is there a path that contains the string CB, something like this. Let me draw the try here to the root, and from this array we could build because we add the string to the prefix every time, so we could reverse the each word in the list and build a try here like this. We gonna build like the root here, we gonna build B, you see B, this is C, and this is C2, and the next level is gonna be A, and this is okay, the C here become a B and like A. This is the try we build from this set of word. Like we don't build the prefix tree, but like we reverse it. It's kind of like suffix tree. Actually it's try for prefix, so we could quickly check if a string already in the set by just adding 1. We maintain the pointer every time we search for new character, like start from empty, we add the C here, and we search to move the pointer to the C, and that's, of course, there's already a string C. I will mark a note if it's a leaf or not. So in this case, C is already a leaf because already form a string like that. So I will add DP like DP2, then move to the j equal to 1. That means the string now is BC, and just look up the next B. That is, we already have the CB here. Actually we got CB, but it's not the leaf. Okay, you can see it's not the leaf. This is a leaf, this is a leaf, this is a leaf. The leaf I mentioned here is just like at that node, this is actually a string in the set. So now we move to the 0 equal to 0. It's gonna be ABC, and actually there's one ABC. So that's my idea to reduce the search complexity. Like we only it's only take us overall ON because every time we move the pointer tree to the left, we only need to like go deeper one level on the try. So the overall is gonna be OL square. So about the space we need to build to store DP is gonna be L, and the try is gonna be the total size of the, maybe the worst case gonna be total size of the A. So yeah, I think like that's how to do it. Like I think it's called as like the actually the sum of the length of every word in the list in the worst case. No, plus sorry, plus.
Oh, that makes sense.
Yeah, that's maybe my solution for this problem.
Yeah. So I think it's gonna be good for now. But have you like considered the case where the worst can use multiple times?
Like this.
No. For example, you have like a setting like this. The A, so you can use an A multiple times. So your solution covers.
I beat multiple time. You're right. Yeah, I think it's cover that case too. I just test like sorry. Oh, what the hell? Okay. For the AB here, we're gonna find the solution. Yeah, so I call it db2 is equal to 1, for example, and the db4 here, as with 10, the string gonna be the string we need to search gonna be B, then become AB, and then become BAB, then AB like that. And the B we search in the string, there's already 1, so it's gonna be dp3, and the string AB is already in the try to, so it's still add to the string. So it's the case duplicated. We could choose a single word multiple times. It doesn't matter. So I just use the try here in order to search faster. It's not affect the result.
Yeah, okay, I see. Just give you more about sorry. Just give you more about the requirements.
Yeah, I see. I already see that.
So I think your solution is good, and I don't see any like a bug, an error in your solution. I think you can start implementation now, and I will give you a follow.
Okay. I just want to avoid implement the try here.
But you can give me more another solution that have equivalent everything.
Okay. So this is solution 1. Let's use try. I think we could have another solution like we just need to hash the string, because each time we move the pointer tray to the left, the string gonna add only one character. So we just need to hash the new string based on the previous result. For example, you got the hash A, hash the hash, so the new could be the hash hash of B is just the first A, just something like that. So I'm gonna hash like BA, like hash BA, reverse the string. The idea is same as the try here, reverse the string. So because we add it, we move to the left and we add the left character to the end of the string. So I will reverse it for fast calculator hash function. It's gonna be in general, it's gonna be let's call the previous string a prefix S. We already had the has a prefix s here, and actually we need to calculate the has a prefix, the new prefix actually s plus we add new character here like c, and so actually is equal to the period has here plus something. So my hash function is gonna be something like convert the string to the base. Oh, actually, I want a question like this: the character set of this string gonna be ASCII or could be wider.
Yes, it's gonna be ASCII only.
Yeah, ASCII only. So I think I will hash this by convert it to base. I sample base is only contains 20 ASCII, so gonna be like this. ASCII contain 256 character. So I will use the index. I will convert the string to a base, this base to a number in the modulo. This is my hash function, maybe modulo 9 plus 7, something like that. This is my hash function, and I will calculate the new by the previous hash. So it just take O1 every step. And so it overall is still O(n) power 2, and the space. Actually the space. Actually we need to. In this case, I need to fact check if this has already in the set, and initially I need to hash on the string in reverse order, because my implementation gonna something more like suffix rather than the prefix. So I will reverse the string x string and calculate the hash for on. So the space gonna be n for the db state, and for the size of the map I will use a hash map to store on the hash. So it could be that is my solution. It changed a little bit.
Yeah. And as you improve the space capacity now, and it's easier to implement now.
Yeah. So
but my question is, do you actually need to reverse the string? Because you only like getting an index, not look like the reverse one. You did the try tree.
Oh. So, reverse in the try tree and it's reverse, but in the hash here, actually we don't need to reverse it. Just actually we calculate on the hash function, and then we could get a hash of any substring in O1. So we don't need to reverse the string anymore, but we need to store extra hash. We need to store extra hash array here. Do we need to? Yes, we need to store extra hash here. So it's gonna take L2. So maybe it's not better than my previous solution.
Yeah,
so,
yes, right.
So reverse maybe reverse maybe space efficient more. So I prefer this implementation.
Yeah. I see. But do you have like when you touching to the hash, so how you can handle the conflictions?
Yeah, you're right. So in this case, I have two approach. The first one is like try with more like hash with more modular. That have reduced the chance of conflicts, but that's not 100%. It's gonna some counter test case. So another way is just like do like the hash map. We need to store the like for each map we're gonna store the links of on the hash map that have the same hash value on the string that have the same value, like A, B, C or something like that. But overall it's gonna be O1 at all. It's my two approach. But for simplification, like, can I just implement the one hash function? Like,
Yes, one is good enough.
yeah. So could I start the implementation now? Is
Yeah.
okay. I'm gonna use C++, because it's my more familiar language. Okay. So first of all, we need to calculate the hash function. For example, like function like int, like cow weights, for example, gonna receive a vector of string. I call it like words, and the target string here like t. Okay, so
Right.
it's gonna really calculate the hash. So of each word, words, I calculate the hash like let me see. Long and hash value is gonna be 0 as the beginning. I will define the modulo here, the hash mod here. I will use this prime number, this thing. And actually the mod we need to is the same. Okay. For x string, x character in this word here, and calculate by this function, convert it to the base. I think I've used a prime number instead of it's best practice to use a prime base. Yeah, so I will choose number and plus the C map. Maybe C. Okay, maybe C. Okay, we have the ASCII character set. And we also need to modulo. Make sure not overload, so I will cast it to long. Hash mode here. Yes. So store in the map, like an order map, a hash map. Long like long counts. Okay, like this is for lookup, and the lookup of hash we gonna increase. It must gonna solve the case if there's duplicate string 2 by just store the number. But in this case, we don't need it because there's no duplicate. In this case.
Yeah.
So
Okay.
now do the DP. We're gonna create the DP vector here. Actually, that is equal to the size of the to the length of the target string plus 1. Okay, we index from 1 on 0. The base case DP 0 equal to 1 and from to L. So we need to form tray here to 0. No. Sorry, only 1. And the current string, we got the current hash here. Reverses hash like base plus the character of the t is actually t, and it's 0 base instead, so I need to minus 1. Yeah. So that is the new hash. That's the new hash, and I will look up if the lookup actually contain the hash. So I gonna dp I plus dp j. J's minus 1. We concat the current string. The current string from actually from j to I. What the fuck? J to I. Yeah. No. This one. There's some concern here. Let me see. Yeah, so we got dbj minus 1, and we need to string from the target string from j to I, and the index is actually from 0, so I will minus 1. I think it's correct. Somehow it's correct. Okay. Okay, that's my solution. Let's check out the solution. The result must be, oh, so luck. Result must be dpl, as we conduct the prefix of length equal to the target string. So let's test this. Ways include an order map here and the vector. All right. The result should be in modulo. Let's test the case I use here. How to create a vector string. How to this. Okay, maybe see. It's gonna return like where the run. Return 1, 2, only 2, but it's actually return 0. Let me see. What the fuck? Let me see what happened to this kind of. Okay. Sorry, I forgot to reverse the string. Man. Okay. I forgot to reverse. That's it. What the? Reverse wrong?
You're using const.
What is it? Const, you're right. Just ignore it. What? Okay, let me just take a look on it. It's like we fall from I. Because we could include the current character. Yeah, it's written 2 now. Yeah, I think my solution is kind of okay now.
Okay. Okay. Do you have any improvement in this? This one I need to let me see. Do you have a better Arduino code on it? I see you are Arduino now, but do you have like any Arduino code right now? So I mean the tools 257 here is where you I know you will encounter the conflictions, but how you can like make it gonna be easier to fine tune.
Okay. So I know what you mean. Like in this case, I'm gonna create a class like maybe like the hash function, the hash function, something like that. And it includes a function like hash receive the previous string, previous hash, like previous hash, and the character type, the new character, and that's it's gonna return the new hash, and I will replace this hash function, like it creates an instance of that, maybe a constructor of the modulo. We could pass it into actually we can pass the modulo here.
I just want you to keep the current code, not change anymore. But I would like to have your code is totally clean, and I would like to make the 257 like its parameters to 52 to be 52.
So I think we just need to make it a constant.
Yeah.
like base. I can
Yes.
do
Yes.
something like this. And sorry, I will delete this.
Yeah. Okay.
We need to make sure it's not overflow, so just cast it to long.
Yeah.
Yeah, to base here, and that's it.
Yeah. That's on.
Okay, it's good.
So I think we are good now. But I have a flow for you. So when the target string increase to the thousands, hundred of thousands.
1,000.
Yeah.
1,000.
Yeah.
Okay, so this distortion kind of is too much slow.
Yeah. And the total character in the string, total character in the total character in the list of words is let me see, is a thousands, maximum thousands.
1,000.
Yeah.
Oh, okay. Well, so we can't depend. The solution must not depend on the target size anymore because it's kind of large. But we could think about the list of character, list of word here. Let me see. So I change approach to use. Let me see how to conduct the solution based on the list of word. Kind of challenge, kind of challenging. Yeah. So I think we still need to keep the DB solution here. But how to make it better, like but with this solution I still need to iterate on the prefix is still on. But how can we optimize this? Like okay, I'm thinking about like just based on the each word in the list. So it's only 1,000. It's like we got a string like this, and we check. Oh no, I think my new solution still depends on the target string. Is there any hint for me?
You have do you have any observation on I mean how many different lanes can you get in the list of words?
So the total sum of length in words is something like it's 1,000.
Yes.
So in the for example, if on the words contain only one character, so just there only 26 the unique characters. For example, this when each word is length of 2, so there is something like this character unique string, and the length of the list gonna be 1,000 divided by 2 is gonna be 500. It's still
I mean the maximum difference of string that you can get.
of this list, right? Maximum.
Yeah, yeah. The maximum different length of the words.
Oh, okay. I just missed what you said. Actually, let me write some comment here. The length of targets like 100,000, and the sum of size of words here is could be 1,000. Sum of length of each word here could be 1,000, and the difference. Yeah, it's really long.
That's right.
To get this. So the difference is really large. So it's gonna use some duplicate. So in the worst case, it's gonna create from is it 10 power 5 divided by 2 power 3 is about 100. It's gonna be constructed by at least 100 in the best case where the word is length 1,000, so we need to formulate from 100 word. And in the best case so it's from the number of the word we need to put into to form the targets could be vary from.
No. I mean, you just listen to my question, like answer for me. How many different maximum different length of the word can the word?
Maximum different lengths of the word we can form based on the words list.
I mean not different length, the length of the words, the words.
Different lengths of the word in the list.
Yes, the word.
Different lengths.
For example, you have A, B, and A, C. You have 1, 2, 3, and you have three different, right? If you have A, C or Y, Z, it's still three. The maximum different length of the
Okay. I got what you mean. In this case, it's gonna be square root of 1,000. The number of different length is gonna be 1 or 2 or 3 or 4. To only as square root because the sum is gonna be, for example, 2. The h here is gonna be h plus 1 divided by 2, and I could approximate by using square root. So this square root is gonna be really small. I think it's about 50, 30, 35, for example. It's really small. So a solution of L here, L is the length of target multiplied by this, actually OL.
Yeah, that's right. How you can get it? How you can improve your resource to get that?
Okay. So when as you can see, I extend the string to the left side when I calculate the hash here, and actually the word in the list only the maximum length is only like 35. So we only need to iterate to I minus 35 as define like the mass the mass length. That is, sorry, it's just difference, but it's not the maximum length.
Yes.
Different. So I will store on the different lengths here, and actually we just need to for instead of for on the J position, we just need to fall on J minus the length, which length in the set length here. The set length here means store on the I will define the length h mean it's gonna store on the string of length h like that. So I will iterate on the h possible on the non-empty length h. So based on that, I could search. I will store a set of hash value. So I will fact check, like iterate on the h length here. It's gonna be like maximum 35 values of h, and for h length I will check if a cur hash, as I write here, and if a cur hash in the set length h. Yeah, so it gonna just this complexity. This check only be O1, and the complexity is, as I said before, is multiplied by 65 and equal to OL. And that's my solution. I think it's good.
Those solution is good now. But how you can you need to turn the current hash to a list of the hash. Right.
Yeah, you're right. And because this solution gonna iterate every h character, and it's not in this case not fast enough. We need to add more bit of time, and the space complexity here gonna be as you said before, the hash function gonna start the length, and the map, the lookup here, we don't need to use the lookup here, but we need to use this length, and it actually some of this equal to the length of the list, and this is my okay, this is true. Oh, and the dp of length L. This so it's something like this. The space is L plus n, and in overall we could write at map of Ln. Yeah.
So I think the space to L plus n is the correct the correct one. But okay.
Okay, this must be like this. Forgot the rule of complexity. Okay, so this is my overall solution for the follow-up. Yeah.
Do you think do you have any another solution that you can optimize the space?
Optimize the space.
And you keep the current time velocity.
Okay, this is kind of good here. I think the thing we can eliminate is the length set here. So somehow I still need to store on the hash, and I will try to optimize the DP. No, the DP we still need the DP because there's many states. But where the 2L, it actually come from the hash function.
Oh, sorry. My bad. I think we can not enable the space anymore. Because yeah. Okay.
Yeah. So do
Okay.
you have another solution?
No. I think it's good, and we can move. I don't think we can move to the implementation anymore because I think your solution is
Yeah.
it just works for you.
Yeah. with your hint. Bash,
I think we can guess now.
what would you say?
I think we can finish now
now
because
because
I don't have further question.